Power again. Okay, so we're going to be looking at variation to begin with. This is something that some of my calc students struggled with this year because I don't think they were taught this by their silly teachers when they were in Algebra 2. And we did use this in calculus a few times this year, so it shouldn't be a hard thing. So one of these types of variation you should have seen in Algebra 1. This is direct variation. So here's what direct variation is. And the way that something's read, like in word problems sometimes, you have to like recognize the way the equation's set up by the way it's worded. So we're going to practice that a lot in this section. So direct variation usually appears something like this. It says something like when y, it doesn't have to be y, it can be any variable. Any variables can be in these. But I'll use y. So when y varies directly with x, if a problem says something like that, we express the relationship as, here's what the equation looks like. Y equals kx. So it's multiplication. When I use direct variation, that means multiplication with some constant. K is the constant, could be any number, 2, 3, 1/3, 200 million, anything that's a constant. You don't know what it is yet. Okay? So K
How's your boy Tebow doing?
That's right up. Where K is the constant of variation. Okay, so that's the first type of variation, which you should have seen before. These other ones you might not have.
Which type?
Okay, we've also got inverse variation. And then we'll have a joint and combined variation. So inverse variation. This one's really easy to remember. What kind of an equation is that, by the way? So, what is it? It's a line, right? This is like the slope. It's like the same kind of thing as a line. So it has no y-intercept, no b, right? So it's pretty easy. Inverse variation is a little bit new and has more to do with the chapter we're going to be doing. So when I say y varies inversely with some other variable, let's say with z, okay? Don't have to use x. We express that relationship this way. It's still got that k in it. It's still got the constant variation. Any kind of variation always has that. Okay? But this time, instead of multiplying and getting a line, you divide and get something else. So this up here as a graph would be like a line, right? This as a graph would be, I don't know, yet. We're going to see what it is though, this first problem. Okay? So this turns out to be a rectangular hyperbola that's restricted to quadrants, quadrant 1. Okay, so we're going to graph that on our calculator in just a second, see what it looks like. It's also our newest class of function, which we're going to be studying in this chapter. It's called a rational function. Okay. So let's look at an example where we have this kind of thing. So this inverse variation kind of thing is used a lot in electrical applications like circuits and so forth. So the current, we're going to say the current I in an electrical conductor varies inversely with the resistance that's trying to stop that current from flowing in that conductor. All things, whether they're conductors or not, have some kind of resistance. Sometimes it's low, sometimes it's high, that's trying to resist the flow of the electricity through that surface or material. If it's a conductor, the resistance is usually going to be low because it's going to flow pretty well. They're also going to tell us the current. Current is measured in amps usually, so it's 1/3 amp. When the resistance is 360. Anyone know what resistance is measured in? No. Ohms. Very nice. Okay, so first, let's try to figure out the constant K. Now when we do these problems, usually that's going to be our first step. Take what information we have, figure out that K. It's a constant, but you got to find it to be able to do anything in those kind of problems. You always got to find K first, okay? Find K first. So, first we write down the form. Instead of writing Y equals, what should I write? I equals. It says I, the current, varies inversely, so what's this going to look like over here? K times or K divided by? K divided by, since it's inverse, and then the other variable is R, okay? Then it gave us some info so we can get K. So it says current is 1/3 amp when resistance is 360 ohms. Plug those in, so you get 1/3 equals K over 360. Yeah. Multiply and you get K. So multiply that up there. So K is going to be 1/3 times 360. What's 1/3 of 360? Or 1/3 of 36 divided by 3. 120. And it's just a constant, so it doesn't have like units. Okay, it's just a number. So we found that K is 120. So now the relationship that we could graph is I equals, put it in, 120 over R. That is the thing we could graph. So let's put that in our calculator and see what that looks like. Instead of, our calculator doesn't use I and R, right? So we're going to put Y equals 120 over X in there. So let's just see what that looks like in our calculator. Okay, so we go Y versus right. So we're graphing it. So I go in there, figure out whatever's there, and I just want to put 120 divided by R. X. Remember, you can always change variables to graph stuff. Okay, and then on the graph, remember your graph might have some kind of window different than mine. I'm going to get it back to normal. Standard, zoom, 6, standard. Why can't I see it still? What numbers is it? 120, so maybe I better zoom out or go check, make the numbers bigger. So I was going to zoom out. See it. You can see that hyperbola. It's a little bit different from hyperbolas we've seen before because technically I don't think of this kind of graph as a hyperbola. I think it is a new kind of graph that we can study. It's a rational function. And since this is an application, am I going to probably want to consider this negative branch over here? I'm thinking about positive resistances, positive currents. So I'm just going to look at this piece over here. So that's the graph. Did you zoom out?
Thank you.
Yeah. Maybe just need to zoom out again. Always just go hit window and see what the windows are. And then you can zoom in or out from there. Okay, so I want to do one more thing with this problem. Now let's use it. Because after we have this relationship, we can use it to find the current when the resistance is 15 ohms. Because I might want to know if I've got a specific resistance of a material that I'm working with, like a piece of silver or something like that, I might want to know, okay, how much current can I push through that, because I might need a certain amount of current to run my appliance, right? So I can go ahead and say, okay, just solve. It says find the current, so I need I. They could have just as easily asked us for R. Put in 120 divided by my 15, and I get I as whatever that is. So I get 8, and we just learned that current is measured in amps. These are good things to remember. Some of us won't have the opportunity to take a physics course while we're in high school. Most of us will have to take a physics course when we get to college. So good to know this stuff. Okay. And many of you, I may teach a physics class before you graduate. Okay, does that make sense from our graph? If we had R was 15 ohms, this is I, this is R in terms of the axes. So if I plug in and calculate the value of R, or what variable do we use for R? We used X, right? So if I put in 15, I get 8. Okay, let's see another kind of variation. All right, let's look at combined. So combined variation it involves both direct and inverse. Okay, it's just combining those two things. It's not hard. So let's look at an example with that. Let's say suppose Z varies directly with X and inversely with the square of Y. You have to be careful, there could be other keywords here. What's the new keyword in this one? What's new?
Square.
Square. So the variables don't have to be linear variables. It also gives us some info, because you have to be given some info or you can't find the K. So it says when X equals 100 and Y is 20, Z is 6. Okay, that's our info we can get K with. And then it says, okay, use that to find Z when X equals 54 and Y equals 18. So when you're going about solving one of these variation problems, I want you to think of it as 3 steps, okay? Step 1, set up the problem, set up the relationship. So step 1, we set up the relationship depending on what kind of variation it is, okay? This is the part people usually mess up on. After this, it's easy. So what should I say equals? What varies with the other stuff? The z. So z equals. And it says it varies directly with x, so how do I write that part down? K times x. Yep. What else? So I write another separate equation for this part.
Just divide by y squared.
That combines both, right?
So it's
It's varying directly with x and inversely with y squared. Okay? Then you plug in your stuff and find k. So step 2, there's our relationship, all done. Step 2 is find k. So take your first stuff they gave you, find k, so I'm just going to plug in. So 6 equals k times 100 over 20 squared. And solve. So up to you how you do it. I'm going to go 6 equals k 100, that's 400. Add 6 equals k over 4. It reduces to a fourth, right? And just multiply that up, and k is 24. Okay. KK. So we got k. Now just take it, put it there, and you're done, pretty much. So step 3 is use what you got. So I'm going to put it in, z equals 24x over y squared. There's my finished relationship. It's done. I know exactly what the constant is, and I can use it for stuff. So now it says use it to find z when this thing, but these are those. Okay. So now I'm going to plug stuff in again. So it's kind of like you plug stuff in twice. The first time to find k, the second time to find whatever else. So 24 times 54 over 18 squared. That's just ugly. I'll use my calculator. And let's see. I got 4. Righty. You guys have any questions yet? So that same process applies to most of the problems in here. Set up relationship, find k, use it. Okay? I need to stop saying k. I sound like one of my teachers from high school who I really did not like. We tallied him one time, and I think he said k. Many times. I think it was 126 in one class period. It's hard not to do. You may make fun of me now, but try not to do it. It's difficult.
Or when it's like, he's like, he's like, right. He was trying to say like, any rate. He's like, right. Oh, anyway. He was like,
Okay, this is our, see? This is our last type of variation called joint. Once again, it just combines the variation we already know, so it's still not new. There's really only one new type of variation. Which one was the new one? Direct shouldn't be new. It's linear. You learned it before. The new one's inverse. These are just combinations of those. So joint variation is when one variable varies directly with 2 or more other variables. This one just has no inverse. It's like kind of like double direct or triple direct. Okay. It's so hard not to do. This is too long to write down. So same kind of problem. The only thing you really have to realize is combined. Usually when they say combined, they'll still use like tell you what's direct and what's inverse, so it's like kind of duh. This one says joint, so you have to know what joint means. It means it's just all direct, right? So it's all multiplied. So you just say, how do I start? What varies with what? M. M is the thing that's varying with the other stuff, the other variables. And it says jointly, so we say K. It's always got that K in there, right? K times.
Still does.
Just gonna have to deal with it. And cubed. And P squared. Okay, all multiplied, still only 1K, right? All only have 1K. So then you plug in what you know, so that's step 1. Step 2, we try to find the K. So just solve that. You might want to reduce it. Let's just put that as a decimal. What is that as a decimal? Use your calculator even, right? Either reduce it or put it as a decimal, doesn't really matter. And then my final thing, what they asked me to do ultimately. What's the ultimate goal?
Find M.
Right, I did step 1, I did step 2, I need to find M though. So now I use this, I say M equals 1.25 n cubed p squared, and plug in these things. So I plug those in, and now I just put it in my calculator. Okay. And make sure on these, some of these problems, especially the applications, they're going to have units. If they have units, put the units or you'll get marked off, okay? I have a bad habit. I'm going to have to really work on that. I'm young. It shouldn't be happening yet.
Okay.